Hey class, we're getting started back with homework. This is for WebAssign textbook chapter 2 section 4. We'll be solving nonlinear equations, and the method that we're going to use to accomplish that task is we're going to try to use the crossing graphs method, where we're going to graph one function, then we're going to graph another function, and we're going to try to find that intersection point. That's how you solve nonlinear equations. As with all of these homework videos, you should make sure that you understand what's going on in the problem scenario before you listen to the solution. If you can solve these on your own, that's what you should be doing. That independence is going to help you on quizzes and tests. So go ahead and take some time to read question number 1 from the homework. You might have some different numbers, but I'm pretty sure we should have the same numbers on this one. So in this problem, we have a couple of different variables that we should talk about. We have f which represents like a future value, right? So this is how much our money will be in the future based on how much the interest rate is. They've given us the formula that calculates exactly what the future value of our money is going to be. How much money do we have in the bank if we have different investment rates, or R values. Hopefully you think it makes sense that the amount of money that we have in the bank in the future depends on how much interest is getting earned. How quickly is our money making money, all right? That's our R value. I'm not going to do every part, but in part B it says find the monthly rate R that will yield the desired future value of 100,000. What that tells me right away is that in the future, F, that future value, we want it to be F equals 100,000, right? They just told us that. We're trying to figure out what R value, so R is an unknown variable value, what R value will lead our future investment to be $100,000. We can use the crossing graph method for this. When you're working these problems, what you need to recognize is that we have a function which has been solved for one variable, and then we're told what that variable is equal to. So I have f is equal to 200 over r times 1 plus r to the 216th power minus 1, and f is equal to $100,000. So the way we use the crossing graph method is in our calculator, we let y1 equal 200 divided by r, blah, 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 this whole equation here for f. Then in our calculator, we let y2, a second function, a second graph, be equal to the other value that f has taken on. Okay. Then you're going to use your intersection point. You're going to go find that intersection point, which is going to force you, after you enter your y1 and your y2, very carefully, make sure that you use your parentheses as shown in the function. You're going to change your window until you can see that intersection point. And I'll tell you right now, if you just use the standard viewing window, this method will not work. You need to start zooming out and changing that window until you see both graphs and the point at which they intersect. Okay, that's the only way the calculator is going to be able to find this intersection point for you. All right, so for this problem, I had to search for quite a while to find an appropriate window that showed me what was really going on with these two functions. I had to make my x-min very, very small, and my x-max is still pretty small. It's just 0.1. So the biggest R value, the biggest monthly rate that's being shown in this window is 0.1. All right, that is a very small interest rate. Okay, I had to change my y-min and my y-max to sort of straddle the $100,000 goal that we have. So I chose 95,000 as my y-min, and I chose 110,000 as my y-max. Once you put something like this into your window settings, you can hit second trace 5, that's our calculation menu. The second trace, that's at the calculation menu. And I want you to select option 5. I know it's been a while since we've been in class, but option 5 is the intersect. Okay, so it's going to find the intersection point of those two functions. Then you're just going to go through the prompts at the bottom right of your screen, and whichever x value it gives you, once you find that intersection, the x value, which represents r in our function, that's going to be the monthly rate that will give us the desired future value. So for me, the number that popped out as the x coordinate of that intersection point was 0.0069743, right? Some insanely small decimal value. Now, r, when it comes from the function, is a decimal value. Okay, we were told that in the setup of the problem, but it's asking for a percentage, and you can see how I had to change that x value into a percentage down here at the bottom of the screen. Okay. You multiply the decimal by 100 in order to get the percent. So in other words, the percent is a bigger number than the decimal number. It's just a different way of writing this same fraction. So if I wanted to round that to one decimal place, it would be 0.7%. Okay. So 0.69, I'm looking at that 9, and it tells me I need to round this 6 up to the next number. Okay, so that's the percentage to one decimal place of rounding. So for part C, I don't want to really work it out for you. I don't think that it's that difficult, but once you try to zoom out from using this very complicated formula, I think that it gets a little bit tricky to see how easy this problem is. So I just want you to think about your total investment. This is the amount of money that you actually put into the account, right? It's not, you did not invest $100,000 into your child's education. That's just the future value that you're trying to wind up with. What you need to do is come up with a strategy for figuring out how much cash money you actually invested in your child's education. So think about how long that money was in the account, and think about how many times you had to put money into that account at the end of the month. You need to consider how much did you put in at the end of every month. Okay, that information is enough for you to calculate your total investment in your child's education. For number 2, you should pause the video now and read the question. Make sure you understand exactly what this formula is representing before we get started. As you probably noticed when you were reading this question, there are a lot of variables going on here. This is not a simple linear equation. This is more complicated. So the first thing that you should be trying to do is understand exactly the meaning of each of those variables. In the formula, you see d, n, pi, which is just a number, that's not a variable, a capital S, a capital B. All of those have distinct values or act as variables in the question. So what we can do is just make a note of what each of these things represent in the physical world. I made a quick list of the meaning of each of those variables. Our D is displacement, N is the number of cylinders in the engine, S is the stroke, which is the distance traveled by the pistons in the engine, and then B is the bore, which is the diameter of each of the cylinders. Part A starts filling in what some of these variables are really equal to. They take on constant values, which allows us to calculate different variables. So in part A, we're looking for the displacement of the engine. So we know that we're going to have to use the equation that we were given. It's D equals N pi S times B over 2 squared. So we need to know as many of these variables as possible in order to get started. We do not know D. That's what we're solving for. But we know N. We're told that this Subaru engine has 4 cylinders. It has a stroke of 3.11 inches. You might have different values in your problem, so make sure that you're using the correct values. It has a bore of 3.92 inches. And as I mentioned earlier, pi is not a variable, okay? It does have a symbolic representation. It's this letter here, this is pi, and it's actually the ratio of circumference to diameter in a circle. It is irrational. I cannot write it as a perfect decimal number. The decimal just keeps going on and on. But if you look at your calculator, okay, above the exponent symbol, above the symbol that looks like this on your calculator, you can see the pi value there. So we're going to use that when we do these calculations. Just erase that out of here. Okay. So we're going to use that button in our calculator in order to be as precise as possible. For this problem, I went ahead and filled in all of the known values. We were told that n is equal to 4. We know s is equal to 3.11, and we were told that b is equal to 3.92. You need to fill in all of those values and then use your calculator to multiply 4 times pi, all times 3.1, all times 3.92 divided by 2 squared. Be very careful with your parentheses because you don't want this exponent to be applied to all of these numbers. You only want this exponent to be applied to 3.92 divided by 2. I really wanted to work part B with you because it's trickier than it seems. We are told how many cylinders the engine in question has. We were told that it has 6 cylinders. I'm just filling that in directly into the formula. N times pi times the value for s. We're told the stroke is 3.09. But look what's left. I do not know what B is equal to. I don't know the bore of this engine. We're going to use the crossing graph method in order to find this. Not only do we have a formula for D, but we also have an actual value for D, 125 cubic inches. We were told the total displacement. So we're going to use, like I said, the crossing graph method, where we let one of these equations for D equal to y1, and then we let the other equation for D be equal to y2. Once you've put in y1 and y2, you need to figure out what your window should be. I'm not going to give it to you for every problem. You kind of have to learn to play around with the window until you can see both functions and the point of intersection. Once you can see that point of intersection, you're going to press second trace, which brings us to our calculation menu. And you'll select option 5 in that menu, which is the intersection option. It's going to give you a point of intersection, which will have XY coordinates given in the bottom of the screen. It's important here to remember that Y is your displacement. We already know what our Y is going to be equal to at this point of intersection. It's going to have a Y value of 125. That's given. We told the calculator that the D value, the Y value, is equal to 125. Your job is to locate the X coordinate, which represents the only other variable left in our equation, this B variable, which in the calculator looks like an X value. That's how you're going to identify the bore of the engine that was described in part B. This is another set of questions, number 6 and 7, that have to deal with the crossing graphs method. It tells you straight away that that's the method that you need to use in order to solve these nonlinear equations. We're using this graphical approach because it's a lot easier to use that in the calculator to have it do the work than for you to have to learn all of the different methods for solving nonlinear equations. We will learn more about them later in the semester. For now, I want you to learn this graphical approach. So in number 6, you can see that we have one side of the equation, very complicated, another side of the equation, very complicated. There's only one variable here, it's x. And the question is saying, I need you to find what the x value is that makes the left-hand side equal to the right-hand side of this equation. The way you implement the crossing graphs method when only one variable is present is you let y1 equal the left-hand side of the equation, x squared plus 2. Make sure you use the correct values, not just the ones that I have in my problem. And you let the y2 in your calculator equal the right-hand side of your equation. So x cubed plus the square root of x to the 4th plus 8. That's going to help us find when these two sides of the equation are equal to each other. What we've really done in the background here, the math that works out, is we're saying, okay, y is equal to the square root of x squared plus 2, and y is equal to x cubed plus the square root of x to the 4th plus 8, or whatever your numbers are here. And since y is equal to both of these things independently, they must be equal to each other, which is given here. Okay. We're introducing another variable called y in order to use the crossing graphs method. It's the same method from the other problems where you have your y1, your y2, you adjust your window until you can see both functions and their intersection point. From that, you need to press second trace, which brings us to our calculation menu, and select option 5. It really is the same thing over and over again when we're doing this graphical method. In number 7, there's a slight variation. That slight variation is that there are 2 points of intersection here. We haven't really seen that before. So I wanted to make sure that we talked about number 7. You're still going to let the left-hand side equal y1. This is 8 over, make sure you use careful parentheses here, x squared plus x plus 1. No matter what parentheses you use throughout this problem, if you have a denominator, you need to have an extra set of parentheses around that bottom part, around that denominator. Okay. You're going to let y2 be equal to the left-hand side of the equation, I'm sorry, the right-hand side of this equation, which is just 1. Very simple value for y2 in this problem. Sometimes both sides are complicated, like in number 6. Sometimes one side is complicated, like in number 7. Okay. What you need to do again is go to Window, make adjustments until you can see. I don't know what it looks like. Okay, I have not graphed it myself, but let's say it looks something like this. You need to be able to see both functions and their intersection point. Once you can see that in your window, your calculator can really take over and do a lot of that work for you. What you're going to do is press second trace 5, and you're going to try to find the smallest point at which these two functions intersect. Let's pretend it looks something like this, and they intersect in both of these locations. Well, then you need to find the x value of this point and the x value of this larger, the larger x value for the point of intersection over here. It's only asking for the x coordinates here. Do not input the y value here. The y value is going to be 1 in both instances. We told the calculator y has to be equal to 1. So you're really just trying to find those points of intersection. You're just trying to find the x coordinate for both of those. This last slide is really just to wrap up the discussion for solving nonlinear equations using the graphical method. You need to make sure that you feel comfortable inputting a variety of function types. Okay, that's going to look like square roots. It's going to look like, let me get a pen here so I can show you what I mean. It's going to look like square root functions. It's going to look like things to the 4th power, to the 5th power, to different exponents here. It's going to look like things with a different base, e to the x maybe. You need to find all of these different buttons on your calculator. They all represent different function types that we are going to learn about this semester. You'll become a lot more comfortable as we move forward in doing this. These are just different function types that you're going to see throughout the rest of the semester. Now, if you see a nonlinear equation, meaning it does not have y equals mx plus b form, and it has 2 variables, Both sides of this equation should be treated as a y value. In other words, you could have a y1 equals, you could have a y2 equals, and both of those have only one variable on the other side of these equations. If you only see one equation, this was like number 6 and number 7, where we had something like 8 over x squared plus x plus 1 is equal to 1. I only have one equation here. I need to turn it into 2. The left-hand side becomes y1, the right-hand side becomes y2. Okay? So those are the two different types of situations you're going to find yourself in. You're going to either see two different equations for the same variable, like y, or you're going to see one equation and you have to introduce y. But either way, you're going to be using your y1, y2 method. Adjust your window until you can see the points of intersection, and then you'll use your calculation menu, which is second trace. Select option 5 and follow the prompts at the bottom right of the screen. Okay, if you have any questions, make sure you reach out. You can check WebAssign to see when homework 2.4 is going to be due.